All right. So, first thing, I did not get your test graded. I'm really sorry. My earth science kids took a quiz yesterday too, and so it was like overwhelming.
Well, we're your favorites.
You are. It's true.
Oh my God, earth science,
No. The thing about freshmen is that they just don't really, I mean, they're just little freshmen. Like, they eventually, like, you guys were freshmen once, right? Like, all right. Oh, no, that's this afternoon.
Wait, what's it?
All right, guys, listen up.
Is it called a star lab?
No. Sorry. I'll show you some. I'll show you if we have time then.
My boyfriend's school wants up this thing in the gym and they can go in.
Yeah, we don't have one of those. I wish we did.
I've done it twice.
It's a planetarium. It's very cool. Yeah, they're expensive. All right, you guys, listen up. Stop. Okay, so we are going to get started. We're going to start a new unit. And I was kind of pacing it out. We will get done with it with no problem before the end of the trimester, which is awesome. So my goal is to just cruise through to the end of trimester. I have one more unit, this unit, before then. Does that make sense? One more unit. One more unit this trimester, and then we'll do a few next trimester because, whatever. We'll get there when we get there. But for right now, I do want to, I was going to print out calendars, but I have a couple of different options, and so I wanted to ask you guys what you wanted so that, we were making good decisions. So before I forget, yes, you do have homework problems. 1, 2, 3, 4, 5 of them. 4 of them are honestly just like easy, super easy plug and chug. Like and this one is not very difficult either. Like, I think you should be fine, okay? But write them down so that you do them so we can kind of keep moving in that direction. My question about the end of Tri 2. So this unit has another project in it. That is, it is a project that for which your grade does not depend on its success. If that makes sense. Like, if you build it, you will get points. It has, so whatever. And then there is a I'm not going to tell you all of the details, but if you are the most successful, then you will get a couple of extra credit points. So there's a little competition bit in there, okay? But, so here's my question, guys. We can do this project either the last few days right before the end of the try, or we can do it kind of in the middle of the time between now and then. So I was going to pull the little calendar up so you can see where we're, oh, you can't see because it's frozen. Sorry. What? It's not going anywhere. It's still there. So here is today, right? The end of the trimester, like the day that we have allotted to take our final is on the 26th, okay? So just like kind of reality check where we are and that sort of thing. So the project is like a 3-day deal. So we can either take the test over this material, like the regular test over this material, like the 21st, 22nd-ish. Because I think that's like the first day of our finals would be like right in there, okay? And then do the project, which is kind of like, it's fun, it's hands-on, but, and that kind of stuff. Or if you would rather, and I really don't care, we could put the project and it would probably land like at the end of next week, and then we just finish out and we'd take our regular test on the 26th. Yeah.
I will not be here Wednesday, Thursday, Friday of next week.
Okay. Duly noted. Okay.
I don't want to do it.
You'd rather do the project in the middle?
Yeah, that's what I was
I
going to
would
say. I
rather
think
do
do
it
at the
at the
end
end.
because let's say we do a little bad on the test, but then we do this project,
Then you can bump it up.
it kind of bumps your grade up a bit.
Yeah.
And just so we see where we're at type of thing.
And you're kind of done with finals, like at
It's
the
like a
end when you're
refresher,
not
too.
stressed out and you have just a project for them.
And it, like I said, I
Can you
I do
give
not
us
care at all.
A little bit more information on the project. Like, is it going to be a lot of work, little work, or?
it's going to be, so you can make it what you want to. So the project is to build a mousetrap car, okay? And I'll give you details about that, and I'll tell you how to do that, and I have instructions for it, okay?
Is it like in class video?
You'll have time in class to work on it, okay?
Will
So
you have the weekend to work on it?
So my intention, so if we if we do it at the end of the trimester, probably what would happen is that the 22nd and 23rd you'd work on it in class, and then we test it on the 26th. Okay, so we test it on that Monday, so you'd have that weekend to work if you wanted to, if you needed to, whatever. So that's my intention. We could bump that up though and do it, I would have to look at the calendar and see where it fits exactly, if that makes sense. I really don't care which. So I need to look at the final schedule to make sure that I'm not like stepping on people's toes, but probably like the 21st we would take the test. Something like in there sometime. I feel like the 20th is supposed to be the science test day, but we can adjust because honestly it's 14 of you guys, and yeah, you can advocate for yourselves, right? So yeah. Thoughts? Like I said, it does not matter to me. Should we vote?
Yeah.
Okay.
But if we lose this,
Then-
we're making it a dictatorship. Is it like a communist democracy?
Look at you with all your social studies, blah blah blah. Yeah.
We're in AP Gov though.
Yeah.
Not.
We're not in AP Gov right now.
All right. Raise your hand if you'd like to do the project at the end of the try.
Ooh, good thing we made democracy.
Yay!
Yeah.
All right. We'll do the project at the end. Okay, sweet. All right, perfect. I'll get calendars done for you tonight, assuming that it doesn't take me too long to grade your tests. We'll see, but probably tonight. But we will do the project at the end of the try. I'm gonna write that down so I don't forget our conversation. Okay, fantastic. All right. Any other logistical issues, questions,
Is this going to
whatever?
be a partner project, or do you have to do it by yourself again?
Probably it'll be individual, but I haven't thought about the logistics, so don't complain about things. Let me think about it, and then I'll let you know.
Can you be a democracy on that mode?
No.
Ooh, that's a dictatorship. Communist democracy.
Look at you.
Pretend like you vote, but it doesn't really.
But all of the ballots have only one option on them.
Oh, I guess you teach it all the time. No.
All right. I don't know. I haven't figured out any of that. It's not gonna make or break your grade.
Oh,
Okay, but we still have that 3-point thing if it makes.
Blah
Yeah,
blah
you
blah.
that
3
would
point
not
blah
make
blah.
grade.
We'll figure it out, guys. Stop whining. Here we go.
Wait, I thought
Chapter
you
9.
just said we were getting points from building something good and if it was successful.
Yes, I did, but Promise asked me how many points. That's what I said. I don't know how many points it is.
So
We should make it
technically, if we
500.
build something and
Let's
there's
do the
logic
egg
behind it,
rush
we will
out.
get full credit.
No.
No, because you have to do you have to do your writing about it, right? I mean, that part of it is not negotiable. All right, let's not complain, let's not whine, let's not get upset. Let's do physics, eh? Get out your notes, chapter 9, here it comes.
What is the title of that?
Right? You were wondering, I know.
Is it Newton?
It is not. It has nothing to do, everything has to do with everything, right? Up until now, shh, it's too loud, guys. Shh, 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 shh. Are you coming to hang out up here?
See.
That's perfect.
Even here.
You can move up further if you want. Do you want to move up further? And I can write really big too. Would it be helpful if I turn the lights off? Would that be easier to see?
Nah, don't worry.
You tell me what you want. I help you.
Oh, never mind. I don't want to break anyone's eyes. It's okay. I can just.
You
sit
sure?
there. Yeah.
If I write big, will that help?
Don't worry.
No, I'm serious. I can do that. There's nothing. I'm here to help you. All right. So chapter 9 has 3 major topics. The first one is one that you're going to argue, say, we've been doing this all the time. But no, you really haven't. We haven't really talked about the official definition of the word work. Work. We've been doing work forever. I've been working so hard. This is a lot of work. Don't give me any homework. I have to go to work. Tell me what work is.
Energy.
A definition of work. Give me something.
Force applied over a certain amount of time. I made that up on the spot.
Yeah, you did. It's not right, but I'm going to write it down anyway.
Oh, wow.
Don't write all this down. This is brainstorm.
Is it something that requires energy?
That's all right.
We're just going to do a little brainstorm time. So force, what did you say? Abdul, what did you say? force.
Force applied over a certain amount of time. Applied over time, really, you could say that.
You hate when you step in like water.
Other ideas?
The amount of pressure applied to the area.
Amount of pressure.
Quick question.
Hold on. Applied over, what'd you say, Promise? Over what? What did you say?
Over area. Sorry.
It's okay. Other ideas? What's work? You don't have to tell me a physics definition. Tell me what it is. Energy.
I mean, that's when I think of work, I think
Is this an acronym for something?
No. It's the word. What is it? What does it mean to work or to do work?
put effort into accomplishing
Oh my
something.
god.
Wait.
It says something I was supposed to say.
Oh, so you say it again because I didn't catch it all. To what?
To put effort into accomplishing something.
Put effort into. There's supposed to be two C's there, right? Uh-huh. Something to do with a force?
Yeah, I remember that. And like a force applied, but I don't remember being over time.
I haven't heard my back corner table. What do you guys think? What's it mean to do work? To get paid,
When I
right?
think work, I think of Rihanna and Drake.
Oh.
What else you got?
It doesn't have to be a physics definition.
I wasn't really.
What you got? I feel like you've got something you just really want to say. Is it not school appropriate or what?
No, I just said it's curl backwards. See?
Work
K-R-O-W.
That's not really a definition so much as an observation.
Shoot, right? No.
Sorry. All right, other definitions that you got for me?
It's a reaction.
I'm not going to write that down.
No. It's time for pounding.
All right,
Kind of like force over a certain amount of time.
let's figure that out. Okay, so a force applied over a time is something. What is a force applied over a time?
Boy, that's just, wow, that's just.
You just want to go back to the last chapter, don't you? You just miss it. You're like, I missed that stuff. This is what?
Impulse equals changeover.
There's literally
Yeah.
an equation
At least
up
I know
there.
I got that.
Yeah, literally, it was like, oh, geez,
Sweet.
this is-
Amount of pressure applied over an area. So this is kind of not really. So pressure, pressure. It's interesting. It's interesting that you said it the way you did because pressure is defined as force per area. So that means that you're really just talking about a force. So you just defined a force, which is interesting. It is related to forces. This is true that it is something to do with a force. I'm going to say it's not that one though. It is something to do with energy. We're not going to use that E word yet. That'll come in a couple of days. But yes, absolutely. In fact, do you remember last chapter we had the impulse momentum theorem and it was kind of like it was this thing that like tied it all together. There's the thing that's going to tie in all the stuff that we do in this chapter that's called the WorkEnergy Theorem. So it is a thing. But for now, we're not going to talk about energy because we don't want to go quite that deep yet. To put effort into accomplishing something. So that doesn't sound like a very physicsy definition, does it? But as a physicist, I look at that and I'm like, well, kind of. In some cases, you could say that. So I'm gonna say, okay, we'll take that. That's all right. And to get paid. So sometimes there is a trade-off. And I would argue that the idea of getting paid fits in with this idea of the WorkEnergy theorem and the fact that there's always a trade-off, right? So like you have to put something in order to get something back. Are you with me there? Yeah. And that is true for doing work. It's also true that when you hold a job, and that's what I think you were referring to. Is that right?
I just said
Like-
you didn't get anything from us.
Yeah. So you're throwing it out there, right? So but it's not like you said like elephant trunk. Like you said something that was relevant to work. And the thing that you said was get paid, right? Because you heard the word work and Is that fair?
Yeah.
Yeah. So I think that maybe you're trying to like underplay it, but you shouldn't sell yourself short. It is true that the trade-off leads to the idea of the work energy theorem, we'll say. So Abdul, you were feeling a little sad for yourself because the thing that you defined is very, we've been talking about it for ages, right? Here's the thing. You're very close because the definition of impulse and the definition of work are very similar. Okay? They're not exactly the same. So let me tell you what the definition is for real, okay? Is that it is a force acting over a distance. It's a force acting over a distance. So it's very similar. And in fact, when you have an impulse, you are also often, not always, but often doing work. So that's kind of nice. They are related. Work is, in physics, the definition is that it's a force acting over a distance. There's one little caveat there, and that's really, really important. And that is that the force must be applied in the same direction as the displacement. Have we talked about the word displacement? I can't remember. Did she talk about it a little bit? And I think I kind of like didn't use it a lot because it's kind of a scary word and I don't want you to freak out. But in order to travel a distance, you have to displace something. Are you with me there? Okay. But the key is that you have to go from point A to point B, not from point A somewhere back to point A. Because by this definition, if there is no displacement, that means there has been no work done. The equation that fits with this, and that we're going to use today, work is marked with a W. It is.
I was going to say like a delta or a...
Nope, it's not some crazy. This one is logical. It is a W. So it's force times distance. In your book, it will look like that. Every time I write it down, though, I put it in parentheses and then put two little lines there that are parallel. And the reason that I do that is to remind myself what? They have to be in the same direction, or they have to be in opposite direction. They have to be parallel to one another, okay? Because if the force is not parallel to the displacement, there is no work done, okay? We're going to write this equation down because it's important. I have to like consolidate these a little bit so that we've got some more space. Work is equal to force times distance. I've got 4 examples for you today.
4?
4. I know. Do you have 4 colors? Is that what you were so excited about?
I have 14 colors.
You do 14 examples then.
No, I don't know.
Oh, I only have 4 pens. Just kidding. Just kidding. All right.
I only have 1.
All right. Example 1 involves my cheeseburger. So these examples are not examples that are written down. They're examples that we're just going to talk about and discuss and figure out. And these are practical life examples, ladies and gentlemen. The first one's going to be called cheeseburger. What did you say?
You don't know? Are you not cool?
You never heard of a crab?
Did you ask if I'm not cool? Of course I'm not cool.
No, she said, are you not cold?
Oh, I am quite cultured. The problem is that SpongeBob came out like after I was not a little kid anymore. And my kids aren't quite old enough yet to let, you know what I'm saying? I am sure that I will be indoctrinated.
Just watch it and you'll laugh anyway. There's so many innuendos. It's kind of messed up.
All right.
Watch any of the new ones.
Oh, the new ones are going.
So like
yeah.
the old stuff, like the
season 1,
classic.
yeah,
Okay.
yeah,
Can I get this on like Netflix? I'm sure.
yeah. I'm pretty sure, yeah.
I have SpongeBob on DVD and I watch it every once in a while.
It's the original SpongeBob movie. None of the other ones, but the original.
Okay. Here we go. Cheeseburger. Here it comes. So,
Is that a dog toy or kids toy?
I bought it in the dog toy section, but I have never given it to my dog. I mean, I've literally I have it for physics because I do.
What kind of dog do you have?
I have a Siberian Husky.
Wait,
Why
picture.
have you never done this?
Does it have blue eyes?
Easily the favorite.
Wait, you have to show us a picture.
Not right now.
Wait, what kind
Later.
What's his name?
Wrigley.
Oh yeah, you told me.
Yeah, you told
Does he
us.
have blue eyes? Is he white or is he white gray?
White. He's like
Oh my god.
he's like whitish. Like when he's in the snow, he looks a little creamy colored, but he's whitish. How old is he? I don't know. 7? Something like
I'm
that.
seriously confused.
Oh my god.
All right, here we go. Cheeseburger. So, Angela, you're going to be my cheeseburger consumer. Are you excited?
Yeah.
All right. So, Angela's going to lift the cheeseburger. Okay. From the table to her mouth. My question is, how much work does she do? Okay. So you will need to probably ask me a few questions. We'll need to take some data. We'll need to do some thinking about this because it's not just going to go there. So tell me, what do I need to figure out? I need to find the force of the distance. Look at you with your equation. Yeah, so we need to measure a distance. So set that on the table there, my friend. Okay, look next to you. There you go. Make yourself a little plate. All right. And now you're going to measure the distance that she lifts it when she lifts it up to her mouth. So how far does she lift it?
She went at an angle, but 26.
26 what? 26 centimeters. So the distance that she lifts this thing, we can write that down, a given piece of information. The distance that she lifted it was 26 centimeters. How many meters is that?
0.26.
Yeah. Awesome. Okay. What else do we need to know? The force. And it's the force that Angela is applying to the cheeseburger, right? So let's think about this for just a minute. I'm going to go ahead and draw myself a little cheeseburger. You may want to do the same. So here's my cheeseburger. Like that. Maybe put some ketchup on it. I don't know, and whatever, and some pickles. Okay, so there it is. Now, as she's lifting that from the table to her mouth, tell me about the force that she's applying to the cheeseburger. She's applying a force up, right? Absolutely. She's applying a force up. The force of Angel on the cheeseburger. Okay. Are there any other forces acting on the cheeseburger?
Gravity.
Yeah. The force of the earth acting on the cheeseburger, right? Now, we didn't watch super carefully when you were lifting that cheeseburger. Now, let's think about this just really quickly, kind of as we're watching this cheeseburger lift up. How are the force that she applies and the force of the earth going to compare? The force applied is going to be greater. Why and how do you know? And tell me more about what you're saying.
Because the cheeseburger is moving up.
The cheeseburger is moving up. So if the cheeseburger is moving up, does that mean that this is necessarily larger than this?
They're the same.
It depends, right?
No, it's not. Maybe it is. I don't know.
It's a good question.
No, because since it's moving, it has to be greater. It's accelerating towards her.
So, okay, and I just and this there's not like a one exactly perfect right answer, but let's think about it. As you lift something up, if you lift your water bottle up or your food or whatever it is that you're bringing up to your mouth, are you accelerating that thing? Is it getting faster and faster and faster as it gets to your mouth? Probably not, because if it did, then it might be kind of a dangerous thing to eat, correct? You with me there? Like, hold on, right? It might be a mess. So probably in the distance from, just above the table to just below your mouth, it's probably moving at about a constant speed. Would you imagine? It might be fast if you're super excited, but it's about at a constant speed. You with me there? Okay. Tell me about the force at the very beginning.
That's not what happens when I get too excited.
Yikes.
Grandpa's food doesn't even make me now.
Oh no! Tell me about the force that she has to apply at the very beginning, right when it's on the table to get it started moving. It's going to be big, right? It's going to be bigger than the force of the earth. Tell me about if she's moving it at a constant speed when it gets to her mouth. Tell me about the force that she applies compared to the force of the earth. If they're the same and you have an object, so if they're the same, the net force is what? And then the acceleration is what?
0.
0. And so the cheeseburger is going to do what? Well, it's moving already. Right? So she's, okay, so I'm going to steal your cheeseburger for just a second. Is that okay? So here it is. I gave it an extra little force, and now I'm moving it at a constant speed. I'm moving at a constant speed. The net force is 0. Are you with me there? But I missed my mouth.
You have to change direction.
Well, I have to change something. I have to change my force in order to get it to
Slow it down.
stop. You with me there? Is that okay? So just for just a moment, when you, the reason I do this is because it's kind of weird. Now every time you listen to me, you're like thinking about exactly how much force you're applying, right? So because I know you guys like to do this, and because I think it's also an interesting opportunity, I want to graph this. Right? So here is the table. I'm putting this on the x-axis, which is a little bit funny. And here is her mouth. Okay, so this is going up, okay? And then I'm going to graph the force applied. So this is the force applied. I'm going to mark a spot here that is equal to the force of gravity of the cheeseburger. You with me there? Okay. Just for the very, very first moment, it's going to be a little bit higher than the force of gravity, right? It's going to be a little bit higher. And then it started moving. Now I'm moving it. Assuming that we're going to take it at about a constant speed, the net force has to be 0, which means that the force that she's applying has got to be the same as the force of gravity. And then it's going to get close to her mouth. And then what happens to the applied force? It's going to go down. Right, just a little bit so that it can slow down, so that it can be at a 0 velocity in the upwards direction so that she can get it into her mouth. Okay, so there's a little blip up here and there's a little blip down here, and this is where science is real, right? This blip and this blip they both have to happen in order for this cheeseburger to move. But most of it is just a straight line, about, okay? And this is a distance down here. This is the distance that it's traveling. Whoa, where did my black go? There it is. My calculus friends are going to get so excited because I'm going to go like this. I'm going to color that in. And what shape is that in pretty close to?
Square, rectangle.
A rectangle, right? Okay. A rectangle. And you can find the area of a rectangle, can't you? All of you can. I know you can. You've got a distance, and you've got a force, and the force times the distance is going to give you the area under there, which is also the work. Yeah? How you doing? Is that okay? Okay, this is kind of a big deal. This is kind of a nice thing to know. Okay? That the area under the curve, my calculus friends say, or the, what's that called? Huh? That starts with an I. Anybody? Are you not there yet? Have you guys started doing areas or no? In calc? No, I'm not talking to you. Have you guys done areas under curves yet? Oh, you better. No? Not yet? Oh, maybe soon. An integral? Okay. Is the work done?
What's the I word?
Integral. Integral. Yep. You'll all get to do it when you take calculus eventually, right? The area under the curve is the work that's completed.
Did you
What's
like
that?
calculus?
I love calculus. Calculus makes physics work. Yeah.
Okay, I was like, you refer to it quite often.
Because it's fun. Hi, Camden, what's up?
I hope so.
Okay, well, I'm teaching right this moment, so you can come back maybe at the end of class.
Aye.
Sweet. Cool. All right, so the area under the curve is the work done. Everybody good? Okay, so all that to tell me that the applied force that Angela has is equal to the force of the earth.
Well, I know how to find the force of the earth.
Do you?
Yep.
How do you do it?
Mass times negative
9.8.
or yeah.
Yeah, exactly. Now, you may be like, why in the world are we using a cheeseburger? The reason that I'm using a cheeseburger is because you're exactly right. This is going to be the mass times the acceleration due to gravity. That is super true. Yeah. The reason that I chose a cheeseburger is because a cheeseburger, we'll say it's about a quarter pound, and a quarter pound is equal to 1 Newton. I kind of like that.
Oh.
So we're going to say that that's equal to 1 Newton. Okay. Which means that the force applied is equal to 1 Newton. Is that okay?
Yes.
About. I mean, we got this little blip and this little blip, but the blips cancel out, so that's okay. And the force times the distance, you don't even need a calculator for this problem, but the next one you probably will. So the work is equal to the force times the distance, where the force and the distance are parallel. Are the force and the distance parallel here? Which way is she applying a force? Up. And which way is the cheeseburger moving? Up. So they're parallel, so we can multiply them. Life is okay. So you've got 1 times 0.26. You can do that in your head. What is it?
Wait, is the units Newton meters?
All right, so you got a Newton times a meter. And there's actually another fancy unit for it as well. Okay, but you can call it a Newton meter and everybody will be happy with a Newton meter and everybody will smile at you. But it is also a joule.
Chemistry.
Oh, I remember that from Foundations of Science.
I remember doing this in chemistry.
A joule is a Newton meter and we mark it with the capital J. Easy enough? I mean, there was a lot of conversation there, but let's back up for a second. You know the distance? You know the force? You multiply. You label it with joules. Or you can label it Newton meters and just keep it there, and that's fine. James Joule might be a little sad that you're not using his name, but that's okay. Because Newton was so cool. What? What's that?
Newtons. Newton's game.
Oh, dear. All right.
I say it's joules.
Are any of you employed in the food service industry?
Me?
Yeah, where do you work?
Pizza Ranch.
Pizza Ranch. Oh,
Don't sit there, it's gross.
I don't like Pizza Ranch in general, so I'm glad you said that.
Ranch pizza. Huh?
Ranch pizza?
Well, I worked there 2 years.
Don't eat at Cheddar's. They're new out.
No, I love.
I love
No.
Cheddar's.
Cheddar's is amazing.
Okay, I'm sorry, but I worked there and I was the buster, so I had to do the
I trust you.
table. And they said there was this kid doing the silverware, and they washed it, and then there's like still food stuck to it, so they just like picked it off and gave it to people.
That's gross.
Oh yeah, I've heard that.
Yeah, people are dirty.
Janelle, when you, I spelled your name right? Okay. When you work at Pizza Ranch, you do all kinds of managing and all these fun things. Do you ever have to carry pizzas out to a table to take them to somebody? Okay.
No, listen. So one time, I was
Story
serving
time.
a pizza, and this is like a 10-year-old kid, right? So I was hard, right? So it just came out the oven. So I was putting it on the plate, and it flipped over and fell on his arm. And his mom was like, "Oh my God, are you okay?" And I don't serve pizzas that much.
At some point in her career at Pizza Ranch, she did serve pizzas. And the thing that I'm not going to ask you
I
about.
still do.
Oh, you just don't prefer to do it?
Yeah,
I'm not really talking about the serving of the pizza. Really, all I care about is the carrying of the pizza. Okay, that's all I'm concerned about right now.
It perfectly.
So we're going to talk about Janelle carrying her pizza. So let's draw ourselves a picture. I want to know, Janelle, how far do you have to walk from the kitchen to to a table? Give me an amount.
Like 5 meters.
Okay, awesome. Thanks.
What?
Walks 5 meters.
That's not very far. No.
Okay.
No, it's like you're there.
15 meters?
Yeah, that's-
Sweet. Okay, carrying a pizza.
I said 5.
Oh, okay. We'll do it. Well, it's fine. Maybe they got seated really close to the kitchen, right?
Yeah.
It's okay. Yeah, okay. Carrying a pizza, and we'll say the pizza has a mass of, I don't know, 1.3 kilograms. Sure, it sounds like a good number. Okay. I want to know, how much work does she do?
I don't do very much work there.
Okay. I did. This is simple stuff. We got this.
Dessert pizza.
You wanna know the most requested pizza?
What?
Buffalo chicken.
Ew, that sounds good.
It's okay.
Two different reactions.
My favorite is the dessert pizza.
My little daughter really likes pizza, like it's her favorite thing ever. And her favorite kind is just cheese. But when I ask her what kind of pizza she wants, she goes like orange. Like, I guess, but she's like, orange pizza. I'm like, this is orange pizza. Like, I don't know. All right. Tell me about the forces acting on the pizza, guys. What forces are acting on the pizza? Well, there's Janelle and she's balanced that pizza. She's walking.
What? No.
1.3 kilograms. The mass.
No.
So Janelle's applying a force which way? Up. So the force of Janelle on the pizza. Any other forces acting on the pizza?
The earth.
She's moving. She's already moving. It's moving. Moving. Yep, so she's walking. She's got the earth pulling down. Okay. And tell me about the displacement that she's undertaking with this pizza.
She's moving from the kitchen to the person.
Okay. So she's moving this direction, right? Like this. Yeah. Did you get a number? How much work does Janelle do?
Yeah.
Oh. This is not an art class.
I got it, 6.5.
I drew a buffalo chicken pizza.
I did pepperoni.
I drew a. Oh my god, I hate pepperoni pizza.
I did too, but I have.
And people always request thin crust.
6.5.
Like, I hate thin crust pizza.
Thin crust is
What's the
a-
point?
No.
All right, let's go, guys.
Wait, what is? Oh, F round on
Janelle, this is the force of Janelle on the
Oh, I didn't
on
know
the
that
pizza
one.
and earth on the pizza. I don't know why. But have you noticed that my stylus is working so far today?
Yeah, you probably just fixed it.
Yeah.
I know, right? I was just thinking that. I was like, dang it, I probably shouldn't have said that. All right.
I got 63.
Wait,
Yeah, I
wait,
got
what did I do wrong?
76.
What?
Wait, did I use the right
Wait.
formula?
Yeah,
Or
wait.
did you just take
63.7.
Oh, I got that.
Or did you just take 5 times?
Joules or Newton
No, you have to
meters.
do M times 3, so 1.3 times
Oh my god. Okay. I do that mind.
Hey. Oh. 63.77.
Yeah.
The directions aren't.
What?
The directions aren't parallel.
Oh, that's interesting.
Wait, pause.
Pause.
How do we know?
Which way is Janelle pushing?
Or to the right.
Left or up? Wait,
Look at the picture.
Going up.
She's pushing up, right? Where's the displacement? How much work is she doing, guys? No work is done.
Don't trick us.
I'm not tricking you. I'm helping you learn. No, I'm helping you learn.
Not a fan.
Sorry. Good catch. Good catch.
I forgot to ask about that. Actually, I just assumed she's going left or right. So I was like, really bad too. I learned my lesson.
How far up?
Okay.
So I do want to call out, because Carly did say, she said, yeah, but at the beginning she doesn't get to start. So like at the very beginning, we talked about with this, when we're getting the cheeseburger started, when Angel was lifting the cheeseburger here and here, there was a little bit of force in that, right? Like that little extra bit. So if Janelle's standing there, and she's talking to somebody in the kitchen, blah, 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 the pizza is not moving at all. Are you with me there? Okay. She has to give it a little push in this direction. Are you with me there? So there's a little bit of work that happens, but then the only direction that you're pushing is up. No work, no work, no work, no work, no work. Oh, I have to stop it, right? I have to apply a little bit of force this way, thank goodness for friction. Otherwise, the piece is just gonna keep going and land in her lap. I mean, that might not be unprecedented, I don't know, but
Well, that did
hopefully,
happen,
that's what I'm saying, but are you with me there? But for the most part, during that story, because the force and the distance are are perpendicular to one another, we've got no work done. Okay. Questions so far? Okay. Another question for you. One more. We've got like 7 more minutes. That's perfect. All right, example 3.
Pens are so expensive.
All right, example 3. Anybody here ever helped a family member or friends or your family move? Yeah.
Yeah.
Magda's like, yeah, how about my life, right? Is that true? Yeah. All right. So, Magda, do you want to be the story, the person in my example? Okay.
Excuse me?
Random physics student is helping their family move, okay? Okay. Stairs? Stairs, you say? I'm going to do a ramp.
Try having your dad have surgery twice right before you have to move. Both times so that he doesn't have to lift anything. And then your mom and you have to do it all because your little brother is too lazy.
No, we'll do stairs.
Try moving in the snow.
I did.
It sucks.
In January.
All right. So here is random physics student with a big box.
Yeah, try her bed.
All right. We have to, this is not drawn to scale, obviously. Let me try that again. It's like little, no, I'm at the stairs. All right. So we're going to go up some stairs. We're going to carry that box. Let's say that the box, so carrying up the stairs. Let's say that the box has a mass of, I don't know, 12 kilograms. That's pretty heavy. And we're going to go up. No. You guys are going to be mad if I get rid of my stairs, aren't you? So I won't. Okay. I'm going to tell you that this distance here is, do you want it to be a ramp? You're going to get mad at me if it's a ramp. So we'll do a ramp next time. We'll do this one 6 feet. And we'll do that. This one is 4 feet. And I want to know how much work is done. Don't overthink it though. Don't make it harder than it needs to be. Draw the forces acting on the box. Draw the forces acting on the box. This is where you guys need to be. You need to be clever. You need to be thinking this through so you don't make your life harder than it needs to be, right? Keep it simple, man.
I think I might know what you're doing here.
What forces are acting on the box, guys? The person is pushing which way? Oops, person on box. I almost did, yeah. Force of the earth on the box. How do these two forces compare? They're equal? Are they Newton's third law pair? All right. There was a little hesitation, but I mean, better than yes, which is what my students usually say, so that makes me happy. The work is equal to the force times the distance, where the force and the distance are parallel. So we only need the distance that's going which way? Up. So does it matter how far this is?
No.
It does not. It does not. So you need to know the force, which is going to be what, 12 times 9.8? And you need to know the distance, that is 4, and then you're good to go, yeah? We could have told a story about you.
Oh, we
Darn it. We could do one more. Do we have the numbers yet? Not quite? 12 times 9.8, yep. What's that? Is that for the answer, or is that for
That's for that.
one? Say it again.
17.72. Oh yeah, definitely.
So that's in newtons. And then which distance are we using? 4. And remind me why one more time.
Because it's going up and it's parallel.
Because you only.
Oh, those are in feet. Nobody called me on that. Oh my gosh, that's super embarrassing. Don't tell anybody that I just did that. Whoa, yuck. Sorry about that. That was like terribleness that just happened. I don't know. You can listen to him on the video again over and over. Like just, yeah, I try. We get a number?
470.88.
470.88. Do we believe her?
No, seriously, there's times where I get things so wrong and I need people to like.
Just to verify? Just to like, yeah, give you a little vote of confidence? What are the units?
Newton meters or
No,
joules.
Joules.
Actually, no.
You can do Newton meters though. It's safe.
Me? Everybody? Everybody but you. Whoa. Okay, just because of that, Abdul, we're going to do one more example. Here it comes. I'm sorry, use the next page. Example 4. Here it comes. Abdul is going to walk up a ramp. I know, but you can set this one up. It's a 7-meter ramp. It's got an angle of 30 degrees.
Oh, you wouldn't have.
Oh, I know, right? It's all because of him. Just saying. Just saying. Talking some smack, aren't ya?
And now we're back.
You're welcome.
You've been in here
You've been here a little while.
When did he come in?
A while ago.
20 minutes ago.
You know, so what's the height? What's the?
Can you do it?
We know this. Lickety split. We know this immediately when that's 30.
You do.
Yeah.
We do?
Yeah.
What is it? What is it? What is it? Yeah.
What's the lower leg?
Wait, I don't know.
3.5 root 3.
Oh,
Wait,
Yeah. Triangle 1 root 3 2.
What?
I
One root 3 2.
Oh my God.
That's what she said.
Taking the app.